Students, now you know about the acceleration part. Here we will start the new topic, graphical representation of the motion. It means how we can represent our motion on the graph. Before going that, I will like to tell you about the Cartesian plane. Cartesian plane. क्या है Cartesian plane? In the Cartesian plane, we represent the two quantities. This is known as x-axis, y-axis, minus x-axis, minus y-axis. This is known as origin, O. This is known as first quadrant. This is known as second quadrant. And this is known as third quadrant. And here you have the fourth quadrant. In the first quadrant, the two quantities which we will plot here, both will be plus. X is plus and y is plus. Here x is negative and y is positive. Here both the quantities will be negative, and here x will be positive and y will be negative. So using this Cartesian plane, we will do our graphical work. Most of the time we will do the graphical work here in the first quadrant. How we do that? See, the first graph we do the distance or displacement time graph. This graph can be termed as xt graph or st graph. कहीं पर आपको xt मिलेगा और कहीं पर st, दोनों कह सकते हैं. What you do here, we plot here x-axis, y-axis. This x-axis is known as here time axis. This would be distance. We take here in meter, and usually it is taken in the second. So what we do that distance time graph, or what how this distance changes with the time, this we show here on the distance or displacement time graph. Actually, in the motion, what you see, if the time and distance is given like that, with the passage of time, say after 5 seconds, distance traveled is 10, after the 10 second, it is 20, after the 15 second, it is 30, after the 20 second, it is a 40. It is in meter and it is in second. So we have to represent this information on the graph. How we show this on the graph? When we use the graph to represent this distance time relationship, remember we study the change in distance with respect to the passage of the time. Here time is changing and we are noting down the distance. So it means this quantity we are observing, we are noting the change in the distance with the change in the time. So here we mark the distances, it is 5, 10, 15, 20, 25. And the corresponding distances are 10, 20, 30, 40. Say it is 10, 20, 30, 40 and 50. So you take the point here. Five, 10, 15, 20, 10, 20, 30, 40. So now I have plotted a graph, distance time graph, and if I join these points, I am getting a straight line. This straight line graph is representing the uniform motion. In other words, when we are getting a straight line in a distance time graph, it means it is a uniform motion. On the other hand, if we are having a graph like that, it is a time axis, it is a distance axis, then this is the non-uniform motion. Non-uniform motion. Apart from this, we can plot some graphs in general which gives you some information like that. If we are having a graph like this, ST, time axis, here it is the time, here it is the distance. If the line is parallel to the y-axis, it means there is no motion. Of time is passing out, but distance is not changing. It means object is at rest. If you have graph like this, ST graph, this gives you the uniform motion, and if you are having like this, then it is non-uniform motion. We also can say the constant speed. Constant speed. So, how we can conclude about the speed from the distance time graph or the XT graph? It's very simple. Right now I have drawn a graph here. First point, second point, third point, and the fourth point I have plotted here. 5, 10, 15, 20, 10, 20, 30, 40. This was the distance in meter, and this was the time in second. Slope of the ST graph gives the speed. So how we calculate the speed? Y-intercept upon X-intercept. For the Y-intercept, you select the 2 points here. 2 points here, A and B, considered as a C. Okay, considered as a C. What is the Y-intercept? It is the BC and it is the AC. What is BC? BC is 30 minus 10. 30 minus 10. And AC is 15 minus 5. That is 20 upon 10. It is 2 meter per second. So you can get the speed for any graph which is having the straight line. What do you do? Simply you take the slope. This is the slope. We are calculating the slope. Slope of the ST graph gives you the speed. Y-intercept. Simply take the 2 points. Draw the perpendicular here. Sorry. So BC is 30 minus 10. AC is 15 minus 5. You can select any other point. You can take these two. You will get the same result. Because slope is same. हमें slope हर जगह same मिलने वाला है. Slope is same, speed is same. So this is the distance time graph. In the next class, I will discuss about the velocity time graph and uses. And further, we will go for the equation of motion. Okay, thank you.